Welcome back. At the end of part 1 video on energy and climate change, we discussed that from the period from 1971 up to 2005, the radiative forces has been on average plus 0.5 watt per square meters. Or in other words, 0.5 watts per square meters more radiation power is coming in than going out the system Earth. In the period from 2006 to 2018, the energy imbalance increase was about 0.79 watts per square meters. Although these numbers look very small in reference to the total incoming and outgoing radiation, were you shocked with the result of your simple back-on-the-envelope calculations you just performed? So, next to the carbon dioxide, methane acts like a greenhouse gas as well. The chemical formula of methane is CH4. Methane enters the atmosphere from both natural processes like wetlands and termites and human activities, primarily agriculture like livestock, rice paddies, manure, fossil fuels, oil, gas leaks, coal mining and waste decomposition in landfills and dumps, with microbes breaking down organic matter in oxygen-free environments to release methane. Methane concentration in the atmosphere is increasing, with recent years seeing record annual rises driven by both human emissions and climate feedback loops, warmer wetlands decomposing faster. Methane concentration have increased about 160% in reference to pre-industrial times. As discussed, the human-related greenhouse gas emissions have warmed the climate in the last 100 years at a rate that is unprecedented. To put this in perspective, we consider the last 2,000 years in this figure. I have adopted the figure from the report of the Climate Change 2021, the physical science basis from the Intergovernmental Panel on Climate Change, the IPCC. The graph shows the history of global surface temperature change of the last 200 years. The gray line shows the global surface temperature reconstructed for the period from the year 1 to up to 2000, and the black line shows the observed global surface temperatures from the period 1850 to 2020, as we discussed earlier. The average global surface temperature in 2024 and 2025 were even 1.5 degrees Celsius warmer than pre-industrial times. This figure is from the same report that shows changes in the global surface temperature over the past 170 years. The observed changes are presented by the black line. The black line is compared to the CMIP6 climate models. CMIP stands for Coupled Model Intercomparison Project and consists out of simulation runs from around 100 distinct climate models. The simulation result of the temperature response to both human and natural drives is shown in brown. The simulation results to only natural drivers such as solar and volcanic activities are shown in green. Solid colored lines show the multimodal average and colored shades shows the very likely range of simulations. The human factor is needed to explain the enormous increase from the 1950s. The previous and this figure demonstrate that human influence has warmed the climate at a rate that is unprecedented in at least the last 200 years. To combat climate change and adapt to its effects, 196 countries adopted on December 12 in 2015 the Paris Agreement, which is a legally binding international treaty on climate change. It entered into force on November 4 in 2016. The goal of the Paris Agreement is to limit global warming to well below 2 degrees Celsius, preferable to 1.5 degrees Celsius compared to pre-industrial levels. To achieve this long-term temperature goal, countries aim to reach global peaking of greenhouse gas emissions as soon as possible to achieve a climate-neutral world by the mid-century. The Paris Agreement is a landmark in the multilateral climate change process because for the first time a binding agreement brings all nations into a common cause to undertake ambitious efforts to combat climate change and adapt to its effects. The Intergovernmental Institute on Climate Change is the United Nations body for assessing the science related to climate change. The IPCC prepares comprehensive assessment reports about knowledge on climate change, its causes, potential impacts, future risk, and response options. The IPCC has published in its 6th assessment cycle the important reports in 2021 up to 2023. Here we highlight 3 reports. The first report is on the physical science basis of climate change from 2021. The modeling results of the global surface warming I've shown earlier in this video are adopted from this report. The second report is on impacts, adaptation and vulnerability of the climate change, and the third report is on the mitigation options of climate change. The last 2 reports date from 2022. The first report highlights 5 different scenarios and its impact on climate change in which the annual CO2 emissions are subsequently reduced, stabilized or increased. I would like to introduce those scenarios to you. The graph on the right shows the evolution of the annual CO2 emissions related to human activity in this century considered by the scenario. The graph on the left shows the scenario's corresponding increase in global surface temperature at the end of this century in reference to the period of 1850 to 1900s. The first scenario, here indicated in light blue, is a scenario in which the increase in global surface temperature at the end of this century in reference to that of the period of 1850 to 1900 is limited to 1.5 degrees Celsius. This corresponds to the most ambitious goal of the Paris Agreement. This would mean that by the mid-50s of this century, the CO2 emission should have been reduced to 0, and in the second half of this century, we would need to realize negative CO2 emissions. Negative CO2 emissions implies that we capture and store more CO2 from the atmosphere than we emit into the atmosphere. It shows that right now we have to drastically reduce our CO2 emissions per year. Unfortunately, the real numbers of the CO2 emissions from 2024 and 2025 do not show that trend towards a drastic reduction yet. A second scenario, indicated with the dark blue, would be a good indicator for a target corresponding to a 2 degrees Celsius increase in global surface temperatures at the end of this century in reference to the period of 1850 to 1900. In this scenario, negative CO2 emissions in the last 20 years of this century should be achieved. Even in this scenario, significant reductions of CO2 emissions should be achieved in the upcoming years. The third scenario in orange resembles a world in which the CO2 emissions will still slightly increase up to 2040 and stabilize in the 40s and start to drop from the 60s. Such evolution of CO2 emissions would lead to around a 2.7 degrees Celsius temperature increase at the end of this century, which would reflect a disaster scenario, a world in which many habitats would be threatened by extreme weather events at high repetition frequencies. The current trend of CO2 emission is unfortunately most in line with this scenario. The last 2 scenarios resemble scenarios in which the CO2 emissions would be doubled or even tripled, corresponding increase in global surface temperatures to 3.6 and 4.4 degrees Celsius respectively. It is out of the scope of this video lecture, but the IPCC report tells us further that human-induced climate change is already affecting many weather and climate extremes in every region across the globe. First, evidence of observed changes in extremes such as heat waves, heavy precipitation, droughts and tropical cyclones, and in particular their attribution to human influences, has further strengthened over the last years. Climate change is already affecting every inhabited region across the globe, with human influence contributing to many observed changes in weather and climate extremes. Secondly, many changes in the climate system become larger in direct relation to increasing global warming, or in other words, more CO2 emissions. They include increases in the frequency and intensity of hot extremes, marine heat waves and heavy precipitation, agriculture and ecological droughts in some regions, and proportion of intense tropical cyclones, as well as reduction in Arctic sea ice, snow cover and permafrost. These graphs show that if we would like to meet the commitment set in the Paris Agreement, we should act now and realize as soon as possible drastic reductions in the CO2 emissions. That implies that our energy infrastructure that heavily depends on fossil fuels and CO2 emissions needs to be turned into an energy system based on renewable energy technologies. In such energy transition, renewable electricity, like solar electricity and wind electricity, will become the dominant energy carrier. In summary, in this video we have discussed the physical principles behind global warming and climate change, and the role of greenhouse gas emissions like CO2 emissions related to our energy system in global warming. The 5 scenarios of evolution of CO2 emissions from the latest IPCC reports demonstrate the challenges that lie before us to meet the commitments of the Paris Climate Agreement. It starts with drastic reductions of our CO2 emissions and a crucial energy transition in the upcoming years and decades. In the next video, we will look in more detail to the important aspects of the energy transitions. So, see you back in the next video.